In this video, we're going to review how to maximize utility when we're lucky enough to have an interior solution. Luca likes to paint and sit in the sun. His utility function is 3x times y plus 6x, where x is the number of paintbrushes and y is the number of straw hats that he consumes. The price of a paintbrush is $1 and the price of a straw hat is $5. Luca has $50 to spend on paintbrushes and straw hats. Our goal is to solve for Luca's utility maximizing basket. What do we need to know in order to solve for this utility maximizing basket? We need to have a utility function. We also need to know the price of each good. And finally, we need to know the consumer's income. How do we solve this question? We're going to solve it using the tangency condition, which tells us that the ratio of marginal utilities has to equal the ratio of prices. Now keep in mind what this tangency condition really is. We're setting the magnitude of the slope of the indifference curve equal to the magnitude of the slope of the budget line. So we're ensuring that we are achieving the highest possible indifference curve that is within our budget. And that's where the second condition comes from. So we also need to be on the budget constraint. Budget constraints have the standard formula of the price of x times x plus the price of y times y equals income. So with this tangency condition and budget constraint, we have a system of two equations and two unknowns that guarantees we're on the highest indifference curve that we can afford, or Luca can afford in this case. Let's solve this question. Here's what we know: the utility function, the two prices, as well as the income. We're trying to find Luca's utility maximizing basket. So we know that we're going to engage in this tangency and budget constraint process. And in order to do that, the first thing we need to do is solve for the marginal utilities. So to find the marginal utility of x, we're just going to take the partial derivative of our utility function with respect to x. X appears in both terms, and this partial derivative is going to be 3y plus 6. To find the marginal utility of y, we're going to take the partial derivative of the utility function with respect to y. Y only appears in the first term, so the second term will drop out when we take this derivative. And the partial of 3xy with respect to y is 3x. With those two marginal utilities, we can now set up our tangency condition. So the tangency condition is the marginal utility of x, 3y plus 6, divided by the marginal utility of y, 3x, is equal to the price of x, $1, divided by the price of y, $5. I'm going to call this equation 1. We know we're going to use this tangency and budget constraint method, so we also need to write down the budget constraint. The budget constraint is the price of x, which is 1 times x, plus the price of y, which is 5 times y, is equal to 50. Just so we're clear, the price of x times x, that's the expenditure on x, right? So we take how much x costs, we multiply it by the number of units of x. We have expenditure on x, and 5y, that's the expenditure on y. So we need the total consumer expenditure to equal the available income. Now, with our tangency condition and budget constraint, we should be able to solve for the utility maximizing choice of x and y. What I'm going to do is I'm going to start by solving 1 for x. Before I solve anything, though, I think it's really useful if I simplify this a little bit. So I'm going to cancel my 3 in the denominator with the 3 in the numerator next to y, and I'm going to turn that 6 into a 2. And then I'll rewrite this equation. So I have y plus 2 over x is equal to 1/5. So I did a little bit of canceling, and now because I want to isolate x and find how x depends on y, I'm going to cross multiply. So I have x times 1 is equal to x, and that is going to be equal to 5 times y plus 2. And then we can distribute that 5 in and write that x is equal to 5y plus 10. And I'm going to call this equation 3. Now I'm going to plug equation 3 into 2, and I'll be able to solve for y. So taking 3 and plugging it into 2, I've got, in place of x, 5y plus 10 plus 5y is equal to 50. So this is equation 2 where I've just inserted in what I know about x. And now I can simplify. And the simplification process should be fairly straightforward. 5y plus 5y is 10y. And I have 50 minus 10, which is 40. Now I divide both sides by 10, and I get that y is equal to 4. Now I'm going to call this equation 4. Now that I know that the utility maximizing choice of y is equal to 4, all that's left is for me to substitute that value into equation 3, which tells me how x depends on y, and then I'll know the utility maximizing choice of x. So x is equal to 5 times 4 plus 10. 5 times 4 is 20, so x is equal to 30. So we've done it. Using the tangency condition and the budget constraint, we have successfully solved for the utility maximizing basket, 30 paintbrushes, and 4 sun hats.